All right, guys, welcome to lesson 6.2. We're going to talk about factoring, stuff that you should have seen in Algebra 1 and Algebra 2. Probably not much in geometry, maybe a little bit here and there. But factoring is kind of important skill that you kind of use throughout all of math classes, pretty much, so it's pretty useful. We're going to talk about the 4 major ways to factor polynomials, which is the greatest common factor method. There's the box method, or also known as the reverse foiling method. There's the grouping method, and then there's the difference of squares method. So let's go ahead and see what's up with that. Okay, so let's go ahead and start with factoring out a greatest common factor. All right, the way that this works basically is it's the opposite of distribution. Distribution is where you take a number that's outside of a set of parentheses and you multiply it into the parentheses, right? You don't need to write this. I'm just showing you guys what distribution is, and you guys know all that. So, well, factoring is like factoring out a greatest common factor is the opposite of that. It's basically where you ask yourself, what do these two terms have in common, and what can I divide out? Okay, so that is what we'll be doing here on this one. So let's go ahead and put some parentheses here. We're going to have 3 blanks. We're going to have one out here, and that's going to represent our greatest common factor. Now, when you're doing your problems, you don't have to write the word GCF there, but I'm just going to put that there for teaching purposes right now. And then what's going to go here is what's left after you divide the GCF out of these two terms. Okay, so let's go ahead and see what's the greatest common factor. Okay, greatest means biggest, common means in common, so they have something in common. So what's the biggest factor that they have in common? So what divides, I like to look at the coefficients first. So let's look at the coefficients 10 and 15. What's the biggest thing that divides into both of those? Well, it's 5, right? And then we look at the variables. So I've got x to the 5th and x squared. So the biggest thing that you could divide out of those is x squared. You can't do anything bigger than x squared because that's the biggest one we have right there. So you can't go bigger than that one. So we could take out an x squared or divide out an x squared. So now let's go ahead and do that. I'm going to divide 10 by 5. That gives me 2. And if I divide x to the 5th by x squared, now I'm going to show my work up here, but you don't have to do this necessarily. X to the 5th, that just means we have x times x times x times x times x. And then x squared means we have x times x. And then these two x's will reduce with 2 x's here, leaving me with x to the 3rd here. Now, obviously, there's a much shorter way of doing that. And basically, you're just going to subtract this number and this number. 5 take away 2 is 3. Okay? Now, as for the next one, once again, 15 divided by 5 is 3. And then x squared divided by x squared is 1. But we don't really need to write times 1, right? Because that's just going to be 3 anyway. So there we have it. So this is our final answer. If I want to write it nice and clean here, get rid of all the extra stuff. But this is what our answer would look like. And that means that's factoring out a GCF there. So let's have you guys try one of these here. You guys try factoring out a GCF on this problem. All right? Go ahead and pause the video here, and when you're all done, you will see the solution. All right, so the greatest common factor would be 7x. The biggest thing that goes into 21 and 7 is 7. And the most number of x's you could take out is only 1 because this factor here, or this term has only 1 x to give. So if we do 21 divided by 7, we get 3. And if I do 3 minus 1, that leaves me with 2 x's left. And then 7 divided by 7 leaves 1. And then x and x divided out to basically get rid of the x's altogether. Okay. I want to show you guys a tricky question before we move on. See if you could figure this one out really quick. Take a GCF out of that. Pause the video and give it a try. All right, well, there's only the only number here we have to worry about is 1, so we could take a 1 out, right? But we can take out x squared. which will leave me here with x squared. But I bet a lot of you guys didn't put anything here. Probably just left it as, maybe some of you guys might have put 0, but it's wrong, because what we're doing is we're doing x squared over x squared, which is really, we cross them out like that, but that doesn't mean they go away. That just means you're dividing a number by itself, which leaves 1. And a lot of times we don't actually like to write the 1 just because it, like we did up here when I had the 3 left over. We didn't really need to include the 1, because if you multiplied it by 3, it was just 3. But in this case, there's nothing else there, so you have to put the 1 there. And a good way for you guys to check your work, by the way, is to distribute back into the parentheses. And when you're done, you should end up with what you started. If you don't, something's wrong. Okay? All right, that's taking out a GCF. Let's go ahead and take a look at our next strategy here. And this is factoring trinomials. Now, factoring trinomials, it's the reverse of foiling. So, I mean, you guys remember this from our first lesson, right? You don't need to write this. I'm just making something up really quick. But you remember this, right? We started by making a box. We put the 2x plus 3 here. We put the x minus 1 here. And then we fill in our box, right? All right. Well, in this case, we're working backwards, okay? The final answer for this one I just wrote would be this. Let me write it out. The 1 is the tricky part, this 1x in the middle, because that's nowhere in our box. But this 3 is right here, and this 2x squared is right here. So if we were starting from the ending point, what we know is that this term's going to be going here, and this is going to go here. And it's going to be a little bit tricky, but we got to find the right numbers that go on the outside that's going to make all this stuff work out together. Okay, so I'm going to give you guys some steps on how to do this problem here. Okay, so the first thing that we're going to do is we're going to make a box. And when you make your box, you're going to put your first term up here in the top left, and you're going to put your last term here. Okay, so let's do that. First term goes in the top left, last term goes down here. Okay, the next thing that we're going to do is we're going to guess some numbers that would multiply together to make my first term. So I'm going to put a question mark here and a question mark here, because what we're looking for is we're looking for two numbers that when you multiply them together, we get that first term. Okay, so what times what will make 6x squared? Well, there's a lot of different possibilities you could pick. There are, you don't need to write this, but I'm just going to write them off on the side really quick. There's 2x times 3x. There's 6x times 1x. There's 6 times x squared. There's 2 times 3x squared. There's 2x squared times 3. I mean, there's a lot of different things you could pick. But I just want you guys to know that your x's are always going to get split up evenly. So notice how there's x squared. That means I have two x's being multiplied. Well, whenever you do the box method, half of the x's go here and the other half goes here. So you're never going to break it up where all the x's go in one spot. It's going to be one of these where the x's are split up evenly. Okay, so let's go ahead and let's just pick one at random here, because we don't know which one it is just yet. Let's start off with just doing the 6x and the 1x, and then we'll see if that works for us. And that's kind of how this strategy works, is you just pick numbers and you try the one that you plugged in, and if it works, great. If it doesn't, you got to try again. And that's just unfortunately how these ones work. It's just a guess and check method. So I'm going to put 6x there and 1x there. All right, we're going to repeat that process now. Only now we're looking for two numbers that multiply to make the last term. Okay, so now I'm looking for something times something, and that's where we'll put them, that when you multiply them together, we get that last term. Okay, so what times what makes 35? Well, it's negative 35, by the way. So, well, it's either 5 times 7, or negative 5 times 7, or it's going to be 5 times negative 7. Now, technically, it could be this, but I'll just give you guys a little hint. They very rarely go with these numbers, the extreme ones where you have one that's really small and one that's really big. It's just pretty rare. They're probably going to pick the ones that are closer together. So we have two possibilities. And another thing that we don't know is where they go. So like, let's just say I chose this one, negative 5 and 7. Well, I could put the negative 5 here and the 7 here, or we could put the negative 5 down here and the 7 up here. And they actually will result in different outcomes depending on where you put them. So we have two possibilities right now for what I put in for making 6x squared. I also have two possibilities for what makes the negative 35. And then on top of that, we also have different possibilities about where they may go in the box. And now the big question is, how do we know if we're right? Well, basically right now what I'm guessing, and don't write this, but what I'm guessing right now is I'm guessing that my answer is 6x plus 7 and x minus 5. That's what I'm guessing. These two polynomials, if you were to FOIL them out, would give me this. That's what I'm guessing. Well, the only way to know for sure is if you actually go ahead and take the time and multiply those two things out and see if it works. So let's try it. X times 7 is 7x, and negative 5 times 6x is negative 30x. And we have 6x squared, and then we have 7x minus 30x and minus 35. So do these add up to make what we want them to? Well, let's see. If I add those together, I get negative 23x minus 35. Well, that's not what I want in the middle, okay? So basically what we need to do is we need to find the right combination that makes these two numbers on the diagonal add up to make this middle number, okay? And negative 30 and positive 7 isn't going to do it. So what do we do now? Well, let's go ahead and back up a little bit, and I'll tell you what you do. If your first attempt didn't work, and oftentimes it won't, you're going to try different combinations. Now, my first suggestion to you is that switch the numbers locations first. In other words, don't switch the numbers, don't change what numbers you're using, but just switch where they're at, okay? So let's start by taking our 7 and our 5, and let's switch those around a little bit. Let's go ahead and we'll put the minus 5 up here, and we'll put the 7 here. All right, let's try that. Now everything in my box is going to stay pretty much the same except for these two terms. So let's see what they come out to be if I do that. All right, so now this square is going to become negative 5x, and then the square in the bottom left is going to become 42x. Now we have our 6x squared and negative 35 still. That's never going to change. We want to know, do these two middle numbers add up to make 1x? And once again, they don't. So if switching the numbers locations doesn't work, then what you're going to do is you're going to try a whole different set of numbers. Clean this up a little bit more. All right, so let me erase. Actually, I think I'll leave that minus 5 there. Why not? Now, we said that we could switch the 5 and 7 to 35, but 1 and 35, but I don't think that's going to be very helpful. I told you that it's pretty rare that they're going to ask you to ever use big numbers like 1 and 35. But in case you guys remember, how about we switch the numbers that we're using for 6x squared? How about instead of 6x and 1x, we actually try 3x and 2x? Okay, so step 5 then is if your first guess doesn't work, then try switching the numbers. Change the actual values. Try a different pair of numbers and see if that works. Now let's see. We have 3x times negative 5. That's negative 15x. and then 2x times 7x, which is 14x. So now let's see if these two middle numbers add up to make the middle number up here, or these two diagonal numbers, I should say. Well, 14 and negative 15 makes negative 1. I want a positive 1. We're really, really close. It's not quite right yet, though. I need a positive 1. But here's the good news. Little trick for you. If you ever get the right number but the wrong sign, all you have to do is change the negative from being here to here. Just switch the negative. By doing that, we end up with a negative 14 and a positive 15, and now we do get the positive 1. And we're actually done now. Let's just triple check our work really quick here. 3x times 2x is 6x squared. 3x times 5 is 15x, and negative 7 times 2x is 14x, and negative 7 times 5 is negative 35. So we have 6x squared. We combine these two diagonals together, and we get 1x. And then we have 35. So I know that I've picked the right numbers because by filling in my box, it gives me what we started with. So the proper factorization of this then is 2x plus 5 and 3x minus 7. And it's a guess and check method. There's not a simple way to do it. It's just a nice guess and check strategy where you just go through and you keep trying. So let's review the steps here. Step 1, put your first number here, last number here. Step 2, find a pair of numbers that multiply to make the first number. Step 3, find a pair of numbers that multiply together to make the last number. After that, check your answer and see if it works. If it doesn't work, switch the numbers' locations. If that doesn't work, try some different numbers completely. If that doesn't work, you'll have to switch the locations of those new numbers also. But basically, just keep moving stuff around and trying new numbers until you get a combination that actually works. And after you practice this enough, you should be able to pull it off with some measure of ease. Let's go ahead and do a guided practice here. Okay, so this is going to be a guided practice, and that means we're going to have you guys do each step with me one thing at a time. So the first thing I want you guys to do is the first step. So pause the video here and see if you guys can correctly do the first step. The first step was to put the first term here and the last term here. All right, now let's go ahead and we'll do the next step, step 2. So see if you guys can do step 2. Now step 2 is a point in the game where you and I might have some different outcomes, okay? So maybe you decided you want to do 8x squared times x squared. Or maybe you decided you want to do 4x squared times 2x squared. Okay, those are really your only two possibilities. Now, this is the more extreme case where you have a really small number and a really big number. And as I told you guys, it's pretty rare that they'll go with the extreme ones. So let's start with the more chill ones. So if you didn't already pick this, then go ahead and put it. Now, you wouldn't have been wrong if you put 8x squared and 1x squared. That might actually be right. But I'm just telling you your best bet is the less extreme pair. Now, something that would have been completely wrong is if you didn't split those x's up evenly, right? It has to be, you have to take those 4 x's and split them up evenly. You put 2 of them on the top and 2 of them on the side. That has to be the case no matter what. All right, so let's go ahead and let's try the next step. So let's go ahead and pause the video here and see if you guys can do step 3. All right, for step 3, we're looking for two numbers that multiply together to make negative 9. 3 and 3, and one of those has to be positive and one of them has to be negative. We don't know which one it is. So I'm just going to put my positive here and negative here. All right. Well, at this point, what we're going to do is we're going to complete the box and we're going to see if it works. So let's have you guys find this number and this number, and let's see if it works. Go ahead and pause the video here and see if you're happy with the results. All right, so this number here is 4x squared times 3, which is going to be 12x squared. And this number here times this number here is going to be negative 6x squared. And we know it works if this number and this number add up to make the middle. Well, they're pretty darn close. 12x squared and negative 6x squared makes a positive 6x squared, but we want a negative. Now I gave you guys a little trick for that. What are we supposed to do if we have the right number but just the wrong sign? The strategy is to change the sign. So put a plus here and change this other one here to be a minus. That way the 12 comes out negative now. The 6 comes out positive, which reverses the signs. And now we have our solution. 4x squared times 2x squared makes 8x to the fourth. 4x squared times negative 3 makes negative 12x squared. 3 times 2x squared gives me 6x squared. And 3 times negative 3 is negative 9. And when we combine these two numbers in the middle, we get negative 6x squared. So we have our polynomial, 8x to the fourth minus 9. And the two like terms in the middle combine to make this. So we're good. Oops, this is 4. And then we have our final answer. So here's the final answer. The correct factorization would be 2x squared minus 3 times 4x squared plus 3. Okay? All right, so that was a guided practice. And now I'm going to let you guys try one on your own from beginning to end. So there's a student practice for you. Go ahead and do that one down there at the bottom and see if you guys can find the correct factorization of that problem. All right, and there it is. 4x plus 5 and x minus 3. All right, and that's how you factor trinomials. Trinomials are those polynomials that consist of 3 terms, and that's how we'll be handling those types of problems in general. Let's go ahead and move on to a new one here. Factoring polynomials that have 4 terms. Now, it's a little bit similar to the last one, actually. Only it's a little bit maybe easier. It's hard to say if it's easier or not. I think it is. The reason why I think it's easier is because there's a lot less guesswork involved. So if you know how to do GCF, then this problem will be substantially easier. So first term, once again, is going to go here. Last term, once again, is going to go here. The other 2 terms, it doesn't really matter where you put them. Just put them somewhere in there. Just like that. All right. Now what you're going to do is you're going to take out what each row has in common. So what do I mean by that? Look here at these 2 numbers. What do they have in common? What can you take out of both of those terms? What does 2x to the third and 3x squared have in common? Well, the biggest coefficient you could take out is a 1. That's the only thing that goes into 2 and 3 in common. But they both have at least 2 x's they can give up. So you can factor out an x squared. What's the biggest thing that these 2 terms have in common? Well, they both can be divided by 3. And they both happen to be negative. So I'm going to take out a negative also. But you can't take any x's out because the 9 doesn't have any x's to give. All right, so I've found the GCF in each row. Now you're going to find the GCF in each column. So in other words, for these 2 terms here, the 2x cubed and the negative 6x, let's find out what they have in common. And we're going to put the answer right up here. So what can you factor out of 2 and negative 6? Well, obviously a 2, right? So we could divide both of those by 2. And how many x's can you take out? Well, since the one on the bottom has only 1x, I can only take 1x out. We're going to repeat that process here for these 2, and then we're going to put our answer up here. So what goes into 3 and 9 is 3, and you can't take any x's out because the 9, once again, doesn't have any x's. Now, it's very important that you double check your work here, and what do I mean by double check? Is basically multiply in your box, and you should get the same thing again. Now, I'm going to erase this really quick. You don't have to erase it, but I'm just going to do it that way. And I'm going to multiply and fill in my box. I should end up exactly with what we have up here at the top. If I don't, then something's wrong, and I'll need to go back and check it. But it's not like the last problem where you're guessing and checking and hoping you get it right. If you did everything correctly, you should have the correct answer. All right, so 1x squared times 2x is going to be 2x cubed. Check. 1x squared times 3 is 3x squared. Check. Negative 3 times 2 is negative 6x. Check. And negative 3 times positive 3 is negative 9. Check. We've got it. So the final answer is going to be 2x plus 3 and x squared minus 3. So it's a little bit easier, in my opinion, if you know how to take out GCFs than the last one, because you don't have to guess and check. You have all the numbers you need there, so all you got to do is take out what they happen to have in common. All right. So let's go ahead and let you guys try one of those there. Go ahead and pause the video here and try this problem. And when you unpause it, you'll see the solution. All right, and so there's our solution for that one. Before we go on to our last strategies discussions, well, actually, I don't know if it's our last one, but before we go on to the next one anyway, let's talk about something else with these real quick. So this one's pretty much the same with one little thing to be aware of. All right. So what do these have in common? Well, they both have an x in common at least. What do these have in common? Not much at all, actually, just a 1. How about the columns? What does this one and this one have in common? Well, they both have a 2x squared in common. And then these two have a 1 in common. But you guys will notice that everything that I took out only had positives on it. But look at the inside. We have negatives. Anytime you have a situation where these two numbers are negative, but this one's positive, that means both of these need to be negative. That way, when you multiply negative 1 times 2x squared, you get a negative here. Or when you multiply negative 1 times x, you get a negative here. But the negative times the negative here results in a positive. So anytime you have double negatives in the middle and a positive at the end, just know that both of your terms on the end there are going to come out negative, and it won't be as obvious as the example where we had a situation where both numbers were negative, so we, in the same row, so we could factor that negative out. But in this case, you just kind of have to catch it after the fact. Okay? So that is just an extra little example, something to watch out for the way that signs will play with you. All right, let's go ahead and get back to the regular slideshow here. Let's talk about the difference of squares. We talked about this a little bit in our last lesson, actually. We saw in our last lesson yesterday, or last class, I mean, that when you have two identical binomials being multiplied together, but the sign in the middle is opposite, you just multiplied the two first terms together and you multiplied the two last terms together and you got your answer. Well, we're working backwards today. And basically, that's as simple as taking the square root of this. The square root of x squared is x. You just write that twice. Take the square root of this, 3, and you're just going to write that twice. You're going to make 1 a minus, and you're going to make 1 a positive. And it doesn't really matter which one you make a minus and which one you make a positive. So let's go ahead and put this to work for us here. So when you have a difference of squares, you just take the square root of the first term, and then you take the square root of the last term, and then you make two separate binomials with those square roots, one with a plus, one with a minus. So let's do that with this one. So if I take the square root of this, the square root of 9 is 3, and the square root of x to the 4th is x squared. Basically, if you take the square root of an exponent, you just cut it in half. And so we're going to have that twice here. Then we take the square root of the 25, which is 5 and 5. And you're just going to make one of them a plus and one of them a minus. And it doesn't matter which one you call the plus and the minus. Okay? And that's what we call the difference of squares. Okay, that's one of my favorite ones. Nice, quick, and easy. All right, you guys try number 4 there. See how you do with it. Pause the video, and when you unpause it, you'll see the solution. All right, and there you have it. Square root of 36 is 6. The square root of 81x squared is 9x. So we have 6 minus 9x and 6 plus 9x. And that's that. All right. Now, I want you guys to make a note here on your notes, and I want you to put this: beware. sums of squares are prime. And what that means is they can't be factored. Okay, we're talking about a difference of squares. It has to be two perfect square roots that can be subtracted from each other. But if they ever give you one where it's two squares being added, like if I were to change this to be 9x to the fourth plus 25, you're done. You cannot factor that. It's not factorable. It's prime. Prime means that you can't find two numbers that would multiply together to make that. It's just what it is already. So beware that if you see a sum of squares, that is not factorable. Okay? So we've talked about a lot of different strategies here. I'm going to cross this off. Actually, you should do the same, and we're just going to put box here. But basically, we've talked about the GCF method. We've talked about differences of squares. And then we've talked about the box method with trinomials and the box method with four terms. Okay, so those are the four examples we've gone through so far. But this little tree chart here kind of shows you the process of how you're going to go through factoring polynomials in general. So you're always going to start by looking for a greatest common factor first. After you take out a GCF, you might be able to factor it some more. If there's two terms, is it a difference of squares? If it is, then go ahead and apply that method to factor it again. After you take out a GCF, does it have three terms? If it does, try the box method and see if the box method works. Same thing with four terms. If you take out a GCF and there's four terms left, try the box method. All right? So sometimes factoring is not one step. Every problem we've done so far, we've just been factoring one time. But who says you have to stop there? For instance, sure, if you factor 6, you get 2 times 3, right? But what if I gave you 12? Well, if you factor 12, you get 3 times 4, maybe. But the 4 factors again, right? So sometimes you could factor numbers more than once before you get down to those prime numbers where you can't factor anymore, right? Same thing with polynomials. Just because you take out a GCF doesn't mean you're done. You might be able to do difference of squares or a box method. So we're going to go ahead and show you some big boy factoring problems or big girl factoring problems. That's where basically you have a lot of work to do. So let's go ahead and get started with that. So like I said, the first thing you always do is you start by taking out a GCF. So let's start there. 3, 9, 48, and 144. All of those can be divided by 3. And this one's got 7 x's, 5 x's, 3 x's, and 1 x. So I could take 1 x out. So I'm going to take out the GCF of 3x out of every term. 3 divided by 3 is 1. X to the 7th divided by x leaves me with x to the 6th. 9 divided by 3 leaves me with 3. X to the 5th divided by x is going to leave me with x to the 4th. And so on. Negative 48 divided by 3. And then 144 divided by 3, let's see. 3 goes into 14 4 times with 2 left, 24, so that's 8, and then no more x's. So there's that. All right, but we're not done. I just did the GCF to get from here to here. But now let's take a look at what's left here. There's 4 terms there. And we've learned a strategy for factoring polynomials that have 4 terms. And it's the box method. So now I'm going to see if I can go a little bit further. I'm going to put the first term here. I'm going to put the last term here. And then the other 2 terms go in there in the other 2 spots. It doesn't matter which spot you put them in. And then we take out our GCF for each row and column. So I could take out of the top row there an x to the 4th. I could take out of the bottom row a negative 16. And then for these 2 terms, I could take out x squared. And then for these two terms, I could take out a 3. All right. So now I've got my GCF that I took out. And now I've just broken up that 4-term polynomial into x to the 4th minus 16 and x squared plus 3. Are we done yet? Well, I don't know. We might be able to go a little bit further. So now what we're going to do is we're going to look at each one of these terms, and we're going to see, can I factor them some more? Make some writing space for me here. All right. Well, just so you guys know, the GCF, you'll never need to do anything with that. Once that GCF's out, it's done. But everything after that might be able to go further, like this one, for instance. X to the 4th minus 16. Can we factor that? Well, it's got 2 terms. And when you have 2 terms, you have to ask yourself, is that a difference of squares? Well, it's a difference, right? So I do have a subtraction sign here. And is this a perfect square root? Yeah, it is. How about this one? Yep. All right, well, guess what? We just found a difference of squares. So the square root of x to the 4th is x squared. And the square root of 16 is 4. And we make one a plus and one a minus. Nice. How about this one? Can we factor that anymore? Nope, it's a sum, first of all. And second of all, the 3 has no square root to it that's nice to write out. So we just leave those ones alone then. So this one's done. This one's prime. All right, so I got the 3x is prime. This is prime. Now, am I done yet? I don't know. Let's see. This still has 2 terms. So is that a difference of squares? Nope, because it's a plus. So that's prime. How about this one? Is this a difference of squares? It is. We have another minus and 2 perfect square roots here. So we're going to have 3x. We're going to have x squared plus 4. And then this x squared minus 4 is going to get split up into 2 other factors now. The square root of x squared is x. And the square root of 4 is 2. And we make one a plus, and we make one a minus. Well, we've already said that this one's done. We've already said that this one's done. We've already said that this one's done. What about this? Yeah, there's nothing you can do here. It's just got 2 terms, so the only thing it could possibly be at this point is a difference of squares, and since that's a plus, it's definitely not a difference of squares. This one is a difference, but these are not perfect squares. You can't take the square root of x or the square root of 2 and get anything useful. So we are done now. Everything is prime. So you stop once every factor is prime. So that's that. So once again, how do you do this type of a problem? You start by taking out a GCF, and then see what you can do. If you have 3 or 4 terms, it's a box method. And if it has 2 terms, it might be a difference of squares. Here's a student practice problem. Go ahead and see if you guys can factor this thing completely. All right, guys, so our final answer is up here. So we start by taking out our GCF, which was 2x squared. And if you divide all of these terms by 2x squared, you'll be left with x to the 8th, 8x to the 4th, and 16. Now this polynomial here has 3 terms. And when you have that, you use the box method. And I've got my box for that showing off over there on the side. So if you guys want to see that, if you do the box for that though, you basically end up with x to the 4th minus 4 times x to the 4th minus 4. And then from there, both of these are the same, but they're both therefore difference of squares. So the square root of x to the 4th is x squared, and the square root of 4 is 2. So you end up with x squared plus 2 and x squared minus 2, and another x squared plus 2 and an x squared minus 2. I'll put difference of squares, DOS. Okay, and so there's our final answer. At this point, all of these terms are prime, so you can't do anything else with them. But I just want to show you guys another way to write this answer. You notice how you have the same factors written twice, like x squared plus 2 and x squared plus 2. When you have that, you can actually write it as a square. So for instance, x squared plus 2 squared. Same thing here. We have x squared minus 2 and x squared minus 2. So we could put x squared minus 2 squared. So instead of writing that factor twice, you could just put it in parentheses and square it. Okay. It's hard to say what you guys can expect on your exam, so just make sure you know how to write it this way if you need to. But that's that. And that's the end of our lesson for today. Until next time.